In this video, we'll be talking about improving the range of electric vehicles. Before we begin in this video, I want to make sure that for a proper understanding of this research article, I'll be comparing these ideas that are presented in this article with that of iPhones, so that the audience who are watching this video will be getting a thorough understanding of what's the idea and what's the concept that we'll be talking about. All right, let's begin. So first, what are EVs? EVs are just a better replacement of internal combustion engines that are basically cars or vehicles that use gasoline to travel from one destination to another destination. Now you might ask, why is ICE more expensive? Well, if you take the average cost that your car uses or your car consumes, the amount of gasoline per day, and then you keep adding that for the entire year, we'll find out that electric vehicles are much more efficient, cheap, and on top of that, they are much beneficial for the environment. So for those people who might be concerned about environment, well, electric vehicles do solve that problem. Now, the only problem that we have is when you have good things, there are bad things as well. So one of the drawbacks that the EV has currently is the range, and this is where we hope to solve this issue by improving that. So let's begin. So the first thing that we need to know that the article tells is the current generation of an EV. What we'll discuss is the generation of EVs, the features, the weaknesses, and the problems that prevent us from creating the best possible EV. Now, let's take an example of an iPhone before we move on. So if you remember, the first iPhone didn't have the best RAM, didn't have the much processing power. Also, it didn't have the bigger screen. So these are the main things that we look for in iPhone, for example, when we try to buy an iPhone in this generation. Technically, when the first iPhone came out, we didn't specifically look for all that because we never knew that these things are possible. However, since we now know that, hey, these things are just an improvement or different iterations that might take to make the most efficient EV. So technically, currently, the EVs that are in the market are just the beginning of the big leap that the EV will actually become. So currently, if I were to rate the current EVs, such as Tesla's or Porsche, whatever, that's providing, that's making like electric vehicles, I would tell them that they are the first generations of the iPhone. So this is the best way that I can tell you of what the EV can actually, or how much potential of an EV there is. Now let's look at some of the features that we can use for in-depth description in order to provide as many solutions to improve the range of an EV. First of the feature that we want to know is that this EV can use for personal usage, and it's beneficial because they're much cheaper in the longer run, like I told in the beginning. And because it's cheaper than gasoline, it has much lower running costs than ICE. So in total, what happens is for a user experiences a total high number of efficiency. Now, to top it off, there are also less moving parts compared to an ICE. That's why there are less frictional losses in the whole engine. And this is important because the fewer the frictional losses in the EV, the higher the range will the EV have. So the more amount of miles that you and your car can travel in. So you can set your destination much further as the improvement takes place. And of course, the environmental factor also adds up, is that it reduces the carbon footprint when you purchase an EV. So hopefully in the near future, everyone will start owning an EV, and the problem that we are facing about the carbon footprints will be resolved by itself. Second, the drawbacks. All right, so the first problem we said is the range. The range is pretty small, and it is a limited range, and some of the manufacturers say that, hey, it can travel for 400 miles at full charge, But technically what happens is that when you start buying that vehicle and start using it daily, it kind of reduces every day, just like your phone's battery. Every time first time you buy it, you experience the full amount of charge, say 8 hours, and then throughout the period of time of usage, that 8 hours can turn into 7.5 hours, and so on and so forth. So what we need to do is concern our main focus on how much or how we can increase that range. So another drawback is that if you have an ICE engine, so basically a gasoline and gas is over, you just pull up to a petrol pump and refuel the car, and it takes about 3 to 4 minutes on average, and then you're all set for another 100 or 120 miles. But for an EV, that's not possible. It has to take 1 or 2 hours for it to fully charge. So the time factor is also a main issue. All right. Now, what we need to do is talk about the solutions about how we can improve it. One of the solutions that this research paper article tells is using a solar energy. How is this possible? So basically we have wireless chargers, right? We can place our iPhones on a charging mat, which is wireless, and then like that, our phone can be charged. Just using the similar concept, it has a transmitter and a receiver coil. What happens is that when you interact these two circuits together, there is a power transfer. So how the coils look like is the same as the one you might be able to see in a wireless power transfer mat, or you can search it up using a mobile transfer, and it uses the same ideology. So what happens is that this concept is basically relied on the roads your car travels in. Technically speaking, this aren't yet developed, but it is put into action in a city called Gumni, which is in Korea. So what happens is your car is traveling, but as soon as you hit a stop, for example, signal, your car is indirectly and charging for you to get an extra mile boost, right? So this is a useful idea, but technically it's not being implemented. So once it's implemented everywhere around the world, then this can be a big leap. Say that you don't have to continuously charge your vehicle. All right. Another thing that we can do is provide some kind of transportation, which it says here, and some kind of trucks or something. You might have seen a cell phone charging another cell phone. I'm pretty sure Samsung has taken out this technology where if you wirelessly charge another set of phone, you can do it using your own Samsung phone. So the same concept is again being used here using the circular coil. And what's happening is that it's wirelessly transferring the energy from one part to another. So say a bus, which is carrying a load of capacitors, is traveling between your car and the other car. Indirectly, what's happening is that it's giving the power transfer to your car. So this is another big leap on how the cars are being charged. And these cars, if it's next to another EV, can be used as a relay node. So this car can charge another car while this car can charge another. And the direct link is the truck. So right now, there is only one place where it's happening, and that's in California. And to talk about the third way to improve the range is improving the inbuilt hardware and the infrastructure. So the current EVs, what's happening in current EVs is that we need to understand the power is the reason why the range can be decreased. So if we use less amount of power, say for our screens that is built inside the car, the screens that are taking less amount of volt per second, then we might use that additional volts in traveling the extra mile. So what we have to do is build the infrastructure and work on it to make as many improvements as possible. And this cannot be done with just one iteration. It can be done in several iterations. So next year you might be seeing a car with a better infrastructure than the car that is present today. All right. The second thing is the improved storage technology. So While we have ultracapacitors and lithium ion cells for the batteries today, as of today, another option would be using the hydrogen fuel cells to make a better replacement for lithium ion batteries, and that can have a higher storage technology. The other one is improvement in motors. So technically, when I started beginning this article, I mentioned that it uses this electric vehicle uses less amount of machines inside the whole machine itself compared to ICE. So what's technically happening here, that since we are already using the reduced amount of moving parts in the motor, what we can do is perhaps use it such a manner that it's more efficient. All right, it's much more efficient, and by efficient I mean it's reducing the losses that's happening in the motor. So currently there might be 70% of losses that might be happening due to friction, but now we can make more efficient and motors that can be reduced from 70 to 60, for example. And then the next iteration we could try to make that 60 into 55% more efficient than the previous version. All right. Another way, and this is perhaps the best way that I've found, is to make a roof that acts as a wind turbine. So, as a normal wind turbine ideology, what it does is when air goes in, right, it produces more electricity for your battery to go. And as it does that, it increases your range for the electric vehicle. So the concept is, if you make something in a similar concept, which is of an air turbine, and place it on the roof, because the car as it's traveling, more the air, aerodynamically, the air goes over the roof much more than the bottom of the car, correct? So it's better if you put the wind turbines on the roof, and as the air goes in, it creates more energy for your battery to go an extra mile. So this is what one of the possible iteration can look like in the future. Technically, it's not present today. So as of today, if you want to go buy an EV, you might just want to hold off that idea and wait till next few iterations come out in order for you to be guaranteed that you're getting the best possible iteration at the time of purchase as possible. All right. And second and last thing that I want to talk about is the impact of driving behavior. So one of the impacts would be driving, let's say, aggressively. Say you just got an EV and you're accelerating and decelerating constantly. So what that does, it creates a big impact on your vehicle battery, and that basically heats the battery up, causing it to reduce the amount of range that you originally were offered. So trying to avoid this kind of driving behavior can also at least maintain or reduce the the range that you might drop by having adopting to this kind of aggressive driving behavior. And one of the things that I want to talk about is the disadvantages of the solution. So while this solution that I've mentioned, such as improvement in motor using the wind energy turbine for driving, increasing the driving range, improve the storage technology, improving the inbuilt hardware, and using wireless power transfer to increase the range, it also has its drawbacks. So one of the drawbacks is that, for example, improvement in motor. Currently, not many research has been done into this place because we're always thinking about another possible way, for example, wind energy. What if we just adapt another rooftop so we don't really have to focus much on motor anymore? But you see, this is the way how it is currently, and what we can do is just provide a feasibility of solutions so the manufacturers can more focused on this kind of factors and perhaps make the best decision on which parts or which kind of factors they would like to be more focused in, whether it could be storage or whether it could be minimizing the losses that are happening in the motor, or perhaps they just want to improve in the infrastructure that the current EVs are using. So in any of them, any of the research that the manufacturers might be doing, it always turns out to increasing the range of an EV. And this is a big deal because every time your EV is at zero charge, you have to wait at least 1 or 2 hours before it is halfway charged or fully charged, depending on the battery capacity of the EV. So that's it for this feasibility and disadvantages. And technically, one of the conclusions that we have is that current generation of EVs can be improved, and one of the things that we might look forward to is waiting for a next generation of an EV. Just like how we wait for next generation of an iPhone, that next generation is going to be much better, much faster. Just like that, the next generation or next iteration of vehicle that come out in the market are going to be much more efficient, cheap, and are obviously going to be eco-friendly, as they emit zero compared to ICEs,